GRC-HORIZON with FIBROBETON, so I was trying to search the name for the presentation, and then we have decided to continue with that. Anyhow, I have to admit that two things. One thing is, after talking after James will be very difficult for me. Secondly, I haven't talked to James before selecting this slide. 1 minute, sorry. Yes. So, let's imagine a small but courage knight standing resolutely before a towering door. This brave knight is filled with boundless anticipation, their heart racing with the thrill of opportunities that lie beyond. With every step closer to the stage, their excitement grows. The knight embodies the spirit of unwavering enthusiasm, ready to face any obstacle and eager to seize the grandest of opportunities. As the doors swing open, the knight strikes forward, ready to embark on an extraordinary journey of discovery and accomplishment. So, the journey of, I would like to emphasize the journey on the last 60 years and also come to GRC, the FIBROBETON side as well, and let's say to compare these both sides. Facade design from 1960s until the present day has been marked by significant changes and developments. 60s modernistic architecture dominated the design of the facade with a focus on simplicity, minimalism, and clean lines. This style was characterized by the use of glass, steel, and concrete. In the 70s and 80s, postmodernism emerged as a reaction to the perceived shortcomings of modernism. Postmodern facades were characterized by a playful and eclectic mix of styles, colors, and materials, as well as an emphasis on ornamentation and historical references. 90s and the 2000s, the focus shifted towards high-tech and sustainable facades. These facades were characterized by the use of advanced materials, which allowed for greater flexibility, transparency, and energy efficiency. The incorporation of sustainable design principles such as solar shading, natural ventilation, and green walls became increasingly common. In the present day, there is a growing focus on integrating digital technologies and smart systems into facade. The use of parametric design, 3D printing, and robotics is allowing for greater customization, precision, and complexity in facade design. I've tried to put from our company's perspective what we have accomplished throughout the time slot, starting from scratch in 80s. What I see here mostly, it might not be an immediate response from the GRC market side, but we are following the path or somehow the needs of the architecture and of the market. Sometimes immediately, and sometimes a little push, a little delays. If I may, for a minute into my company's background, I'd like to tell you what we have been present into the market for 35 years. So we are around more than 500 people working in our facility, 300 in installation. So we do have offices, so there's a typo probably coming, the office will be in England, but there is no, this is typo, but in Russia and in the US, we do have offices. And I have to emphasize that that we are 47th company, industrial company in 2021 in Turkey, which has been on the number of the R&D projects. So we do have a big environment of manufacturing facility. We do have that in R&D center and also design center. And I don't want to tell about the numbers, it's already written there. So I want to jump what we have done until that, let's say, time. So if we look closely, what we have started from is that the decorative elements were the key elements that we have produced as initial materials. Then, of course, the sizes of the projects became much bigger. So the consumption get bigger, and so there was an investment occurring. And then we have come up in the 1990s with a heat insulation system into the facade industry. Mostly the high-rise buildings are more asked in Turkey due to the moving into the main cities. So we were capable of delivering also heat insulation into our existing GRC composition in order to clad more high-rise buildings. And with additional seismic performances and earthquake tests applied in Turkey, in Kazakhstan, we were able to accomplish more than 1.5 million square meters of facades in the last 25, no, even 30 years with the heat insulated systems. Then, of course, the market was requesting for parametric and differentiation on the design stand, where we are talking all even right now on 3D printing. But from our perspective, in the last 2 decades, we were concentrating on the parametric design forms. Whereas it just started by doing the molds preparation or models preparation, and then, of course, the reality came alive. So, in the sense of the materials and the complexity, it became always bigger and more complexer. Each of us, from the manufacturer side, every day we do have some hassles to, let's say, get above. So, and at the same time, of course, the market was pushing to the manufacturer side into a contractor, facade contractor business. Okay, are we going to enter as a main contractor, or are we going to be a supplier? There was a big question. Some of us, maybe who wants to play bigger, could be entering into a main contractor business, facade contracting business. But in our sense, since we were located in, let's say, I can talk as, let's say, everybody sees his country as the middle of the world, but somehow as we do. So we are staying somewhere, and we had the decision of focusing on the manufacturing side. So therefore we had to collaborate with mainly with the facade contractors and to deliver them ready and finished products. And this enabled, of course, to enter much bigger projects. And most of you are also cooperating with other companies as well, which gives a big impact in the industry in the long term. And of course, in some projects there is a demand for high performance GRCs for more difficult purposes. And these questions and not research but brainstorming ideas, at the end of the day, of course, there is a new material popping up. So we have used on several projects, which was one of the, let's say, one of the inputs that we get is like the third bridge on the top, 320 meters high. It's like a puzzle ended and installed on the ground and lifted like whole floor with a steel frame on the top of the tower. So around 3,000 square meters can be clad within 3 weeks' time. And then, of course, the question were rising about the thicknesses of GRC, because regularly most of us were proposing about the framing of the GRC, framed GRCs. But whereas all the western side of the world is asking for more durable and more, let's say, either stainless steel framed or at the same time price orientation is there, therefore we have to get rid of the frame end in order to continue with the rib systems. So to be able to work with different contractors, we have established these applications as well. At the same time, self-cleaning concrete made visible, more visible, and some of the architects and designers put into their specification, into their design, this self-cleaning concrete action as well. So we have then introduced into a project where we have manufactured and completed that project as well. So if we talk about generally, everybody knows that surface finishes does better in GRC industry. So we are mainly focusing not only on the geometry itself, but also about the finishing, because the idea of the architect, although we are always saying you should be looking from 6 meters and above, they are deciding from the table view, right? Isn't it? You send a 20 by 20 or A4 sample, and then they comment on these by an email, taking the photo above the table. Please see the under sunlight. Take this in front of the building and take the photo under sunlight. You cannot be always with your mock-up piece or sample piece flying to somewhere. Never mind. So, for each of us, this is one of the critical items. Some of you are smiling. So everybody has got the same troubles, and so but we are capable of delivering any kind of solution. Let's continue. At the same time, of course, each market has got his own rules, at the same time his own needs, questions. Some of the companies has invented different things, but we have applied also secondary applications on like brick facades and additional ceramic tiles, apply GRC solutions, where GRC plays, of course, a vital role in order to collect different pieces into one single precast element. So, and then mold technologies. Mold technologies are changing, but as we have been talking, GRC was famous with decorative elements, let's say classical forms, ornamentals. But we are right now forced into a parametric design. Shall we forget what the history taught us? No, I mean, all of us are capable of delivering these kind of solutions. Therefore, engravements, wood molds, gypsum molds, steel molds, as Jan Fay was mentioning, everything is doable in GFRC side, but at the same time, each of us has got a problem of, let's say, polyester's wastage somehow. And therefore, somehow adaptive molds became more popular, and on our last congress, they were giving a speech here actually, and nowadays, the investment continues into that direction, and also CNC machines for mold or model making is also very efficient into GRC's production. So, at the same time, of course, the quality request of each of us gets higher. Why? Because there is only single solution. The market is, somehow the designer is starting to ask more and more. We are, as the manufacturers, saying, you know what, we can do whatever you design. And then suddenly, the request of the tolerances, the request of the quality of the material, shape of the material, gets higher and higher demand. In that direction, we have benchmark from aeronautical engineering, and we have got also invested into reverse engineering to be able, before sending the material or the readiness of the mold, controlling the unit, the produced unit, before sending to the site. And we are all aware that any kind of lamellas, alternative shapes, are capable of deliverable. So these are the units, but I want to emphasize that each of us are talking about the sustainability, so we are targeting apart the GRP output, let's say, polyester output is zero wastage in our site, and as I told you before, the investment into the adaptive molds area will of course decrease the composition or the usage of the polyester molds. And we are trying, first of all, we have invested into solar panel in our factory so that we collect the solar power and using on our daily production fully. And also any kind of wastage, for example, the mixed wastage of GFRC, we have invested into a pavement stone small facility, so we are producing also and working with the municipality and sending these pavement stone into municipalities work as well. At the same time, the polyester foams or the wooden parts are separated into the reuse or reuse of the material. At the same time, we were talking about the LCAs and EPDs, which we all need to invest and emphasize their areas. So, apart from the above products, so we are trying to develop many innovative products in cooperation with universities and within the company. The company is cooperating, as Professor Uğur mentioned yesterday, more than 20 universities, and we can come up, let's say, several items, GRCA, thermal storage material like encapsulated phase changing materials, like thermal energy storage material, or radiation shielding material, where we can use instead of lead sheets. Or we have cooperated with a designer, industrial designer on an VNR by designing a cotton fabric and spraying on the top of cotton fabric and strengthening the really stressed conditions. We have focused in the last 2 years about noise barrier systems, where we can use mostly locally in the local market. There is a new regulation popped up. Some of the European countries have got maybe this regulation more than 30 years, but nowadays we are getting that more asked. And since we were profiting of the normal reinforced concrete columns with GRC, is Professor Demir has talked about that for 10 years. There is a project continuing with an university in Turkey, microcapsules, so that there is. So I do have 2-3 minutes. Okay, sorry. Okay, the investigation of behavior, high blast resistance, solar decouplement, and 3D printing, and also electrical conductivity. I have brought you a single package mod. Let me. I'm just touching on a concrete surface actually. So, like this is okay. So, sorry. Okay. And what do we foresee for the future? 2 minutes. We want to clarify an understanding before we come up with a vision for the future. Our business is a timeless business. Production methods, technical specification may change, but the solid and durable need on the material side will remain the same. Sustainability is one of the most important agendas for the future. In line with these targets, studies should be carried out to develop alternative binders to cement in order to reduce the carbon footprint. Sensor concretes, capacitors, thermochromic, photochromic, thermoelectric surfaces can be developed by giving new usage features to GRC. It is clear that 3D GRC applications will gain speed, and the next Congress more presentation will come up on that Subject: GRC production can be progressed by integrating adaptive molds and 3D printers. Studies can be carried out many different topics such as surfaces that generate or store electricity, smart surfaces, the use of nanotechnology in GRC production. And with his 35 years of experience in collaborations with universities and strategic cooperations, my company highly dedicated itself to this sector. However, this dedication alone is not enough for the development of the market. It's also necessary to increase your input as well. In this way, trust in the market will increase and ambience will be created to produce new solutions that meet current and future needs. And as I conclude my presentation, I just want to mention that we want to continue our journey forward with childlike wonder, eagerness, excitement, and curiosity to greater heights on the horizon. As we work on even more special projects and unique buildings, we cherish the idea that this journey can be alongside those like yourselves who share the same outlook and passion. Thank you very much for your time.